So now here guys, when we talk about science paper 2, when we talk about science paper 2 here guys, science paper 2 which is commonly known as chemistry, which is let me say science paper 2. Okay, when we talk about the same science paper 2, okay, so science paper 2, we best refer to each to be what? To be chemistry. So as for tomorrow, you will be sitting for chemistry. You will be sitting for chemistry. So guys, here guys, science paper 2 which is chemistry, it is just more like biology. The subject which you will be sitting for tomorrow, it's more like biology. Alright? What I can simply say is when they bring everything when it comes to grade 10, they bring everything when it comes to grade 11, and also they bring everything when it comes to grade 12. That's how it is. So when we talk about chemistry, guys, it's more like biology, all right? They bring all the topics. That's what it is, okay? When it comes to grade 10, they will touch. When it comes to grade 11, they are going to touch. When it comes to grade 12, they are going to touch. That's what it is. That's how chemistry is, all right? So here, it is very much essential that you try by all means to understand something, all right, concerning the same part of chemistry. Now, guys, if we pay extra attention to the way the same chemistry is, since here we have grade 10, grade 11, and also grade 12. So now here, guys, as GCEs, all right, you will be sitting for final examination tomorrow, all right? You will be sitting for physics, for chemistry examination tomorrow. So now here, what you must know is this. When it comes to you guys, for the part of GCE, this is what you should do. Now, guys, what you must understand is this. The first key thing that you have to do is this. Number one, entering the examination room minus you knowing organic chemistry, yeah, you will end up losing some marks, all right? So these are some of the key things that one must know in order for him or her to get something when it comes to chemistry. So at least I do understand that we do have grade 10, 11, and 12 work. Now, looking at how time is, all right? So this grade 10, 11, 12, like for all those who started tuitions quite early, they have covered when it comes to grade 10 up to grade 12 work. But now there are those whereby you started tuitions late, all right? Let me say it was, let me say this year, January, whereby most of the topics you found that, okay, your friends have done, all right, did already. So these are some of the key things that at least you must have an idea when it comes to, all right? So here, organic chemistry, when it comes to the part of more concept, okay? So these key things are very much essential when it comes to chemistry, okay? Entering the examination room minus you knowing these, you are very much at risk. So speaking of the likes of nanometers, okay, so these, they do play a very important role. So nanometers, whereby preparation of nanometers, speaking of how they prepare oxygen gas, how they prepare hydrogen gas, how they get to prepare carbon dioxide gas, these are very much important that one must do what? Must know. Here, whereby you'll be asked to do what? To prepare oxygen, how oxygen is prepared. Take note, this question also comes in form of a what? Of a diagram, all right? Whereby you will be given hydrogen peroxide, then now the catalyst won't be given, but it will be indicated. Okay, they can end up putting a letter, then they will say name this catalyst, all right? Then afterwards, they also ask you about the name of the gas that will be produced. Then they also ask you saying that why is the gas on top, then water down, all right? What is the purpose of the gas being up, then now the water is down? What is the purpose of the catalyst? So what are the uses of oxygen? So these are some of the questions that you may be asked under what? Under preparation of oxygen, all right? Then aside from this, also here, asking you to do what? To do as wise in terms of preparing carbon dioxide, how carbon dioxide gas is what? Is prepared. Then we also have the likes of ammonia, how the same ammonia gets to be what? To be prepared. Then we do have the likes of what? Nitric acid. Okay, nitric acid. Now guys, if you check, this is hard labor. You check, huh? This is hard labor. We have oxygen, carbon dioxide, ammonia, we have what? Nitric acid, and not forgetting hydrogen. All right, we have hydrogen, here, how hydrogen gas gets to be prepared, and also we do have the likes of nitric what? Nitric acid. So these things which I've just listed here, they do fall under nanometers. They can get two from here, whereby the other question will be in section B, then the other part will be in section C. You see, ka? So here, organic chemistry, more concept, nanometers. Then now here, we do have the likes of what? We do have also the likes of extraction of metals, extraction, extraction of metals. Because entering the exam minus you having no idea when it comes to these, tomorrow you may end up thinking as if chemistry is very much hard. Okay, you may end up thinking as if chemistry is very much hard. Okay, because whether you like it or not, tomorrow you are going to meet this. They are in your paper. Okay, organic chemistry is in your paper, more concept is in your paper, non-metal is in your paper, extraction, it's a must. All right, so extraction of metal, whereby you'll be asked to do what? To explain, or rather, let me say, you'll be given a diagram, then now you'll be asked to name the raw materials. All right, how the same, how iron gets to be what? To be extracted. We do have the likes of copper, how copper is extracted. Okay, how aluminium gets to be what? To be extracted. Okay, how iron is extracted, how copper is extracted, how aluminium is extracted. Okay, so how iron, copper, aluminium, and not forgetting one. So here we have copper, we have iron, we have copper, and also zinc. All right, under extraction of metals. All right, so now here, the other part, guys, chemistry, it's more like biology. Okay, it's more like biology. Grade 10 up to 12 work, they will be there. Okay, so now here, number 5, speaking of the likes of the same bonding. Okay, number 6, speaking of the likes of the periodic table. You see all these topics, right? Now let us assume that, okay, you started tuitions late. Okay, what are you going to do? What are you going to do? Okay, so I will show you something. I will show you what you will do. All right, so here 1, then up to 7. Here we are going on number 7. So organic, more concept, non-metals, extraction, bonding, periodic table. So these are very much essential. Then not forgetting this major key topic, acids, bases, and what? And salts. Okay, we do have the likes of oxides. What is an oxide? And not forgetting the types. And also number 9, we do have the likes of this one, corrosion. All right, alloys. So this is very much essential. Okay, so this is very much essential. Okay, so what you should know, guys, okay, what you should do is this, guys, these topics are very much essential and very much beneficial, because minus you entering the examination room, minus you having no idea when it comes to these key topics, you are, oof, you will be slapped. Now, number 1, guys, number 1, I have organic chemistry. How many are facing challenges when it comes to organic chemistry? How many do face challenges when it comes to organic chemistry? This question strongly goes to you. How many do face challenges when it comes to organic chemistry? seeing the comments. And whether you like it or not, tomorrow this topic is there. Whether you like it or not, this topic tomorrow it's what? It's there. This topic, this topic is in your paper tomorrow. Okay. So now here on organic chemistry, it is very much essential. Me times 10. No, you must not say times 10. It's way too simple. Now, you guys, the problem is that you become so serious in the last minutes. That's the bad part. You become so serious when it is kind of too late. That's the bad part. You may end up thinking as if, okay, that's what it is. So yes, organic chemistry is waiting for you. It's a must. Okay, so let me help you a bit. So guys, here now, when you talk about the same organic chemistry, right? When you talk about the same organic what? Organic chemistry. All I want is for you at least to have something upon entering the examination room, at least you have where to touch. Okay? Not having that situation whereby you are totally blank when it comes to other stuffs, all right? At least you do have that clue when it comes to these key things. Okay? Are we together, guys? It feels very perfect when you are entering the examination room. Okay? Okay? It feels so good when you are entering the examination room if you know something, all right? Not you're too blank, all right? Okay, sir, we didn't see you earlier. We would have joined earlier. Oof. Hmm. Are you sure? Then now here, guys, under the same part of organic chemistry. Here, guys, there are some certain key things that you have to know. There's some certain key steps that you have to know. So in order for you to be very much perfect when it comes to organic chemistry, there's something that you have to know. Number one, you have to understand that when you talk about organic chemistry, we are simply talking about the study of carbon atoms. We are simply talking about that branch of chemistry that deals with the study of carbon what? Atoms. That's what we are talking about. So when you talk about organic chemistry, is simply the what? We are talking about the what? We are simply talking about the study. So this is just the study of what? Of carbon what? Of carbon atoms. Okay? We are talking about the study of what? Carbon atoms. Now, guys, I hope some of us we have come across these strange diagrams in papers, right? Whereby they will end up looking like this. Isn't it, guys? I hope some of us we have come across these things in papers, right? Whereby they end up looking something like this. Almost everyone now, why? Mhm. Almost everyone has come across these kind of stuffs in papers, right? How many have come across these stuffs? You have come across, ka? Upon just opening the paper, or be it a diploid or a paper, you will end up seeing these kinds of what? Diagrams. So this is organic chemistry, right? Upon just seeing this, just know that, okay, we are talking about what? Organic chemistry. Now, if you check verbal, guys, if you check these key things which we have H, 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 H. In this case, this H stands for hydrogen. The H stands for hydrogen, then the C stands for carbon. This is what we're talking about, all right? So here, H stands for hydrogen atoms, then C stands for carbon atoms. That's what we are talking about. That's what we are talking about in this case, all right? So now here, this is the structure, right? So the H, these H's which you are seeing, they do stand for hydrogen atoms. Then the C, it must be here, okay, in between on the middle here. They do stand for carbon what? Atoms. So when we say organic chemistry, is the story are simply talking about these letters which they are in between. In between, that's what we are talking about. Now here, the study of carbon atoms. Now guys, in organic chemistry, we do have what we call a family. In organic chemistry, we have what we call a family. Take note, organic chemistry is simply the study of carbon what? Atoms. Now, in organic chemistry, we have what you call a family. All right? In organic chemistry, we have what you call a what? A family. So now here, according to organic chemistry, we do have a family of four. We do have a family of what? Of four. Number one, we do have a family of alkanes. We do have a family of alkanes. Okay. We do have a family of alkanes. Okay. And also we do have a family of alkenes. You see? And also we do have a family of alcohol. You see? And also we do have a family of what? Carboxylic. Of carboxylic what? Acids. Okay. So here, under the same organic chemistry, we have four families. We do have a family of alkanes, a family of alkanes, a family of alcohol, a family of carboxylic what? Acid. That's what we're having. So these are the four families that fall under what? Organic what? Chemistry. Now, guys, upon just looking at this, you have to know this. We all know, right, that a family contains what? Members. Each and every family has members, isn't it, guys? When we say this is a family of Banda or the family of Mulenga, it must have members in it, right? Like the way you guys are. You can be Mulenga, but you do have your relatives, right? Those members in your family, isn't it, guys? Isn't it? So this is a family. We do have four families. We do have the family of alkanes, a family of alkenes, a family of alcohol, and a family of carboxylic acids. Now, when we talk about the family of alkanes, if we check, guys, we do have the suffix. If you check this one, the alkanes, it ends with this suffix. Check A N E. You see, ka? It's alka. Alkanes. You see, ka? It's alkanes. Then this one, it ends like this. You check, ka? This one it ends with E-N-E. So this one is ending with what? E-N-E. So here we have alkanes, it ends with this. Alkenes, it ends with E-N-E. Then alcohol, this one normally ends with what? With no. Okay. Then carboxylic acids, they do end with what? With noic, whereby you end up meeting a name like ethanoic acid. So noic, 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 these are carboxylic acids. Okay. Now this is their suffix. How they end? All right. Then now here in a family we have members. All right. In a family we do have what? Members. So guys, in alkanes, the first member, it is called what? In alkanes, the first member is called what? Methane. Okay. The first member is called methane. Okay. Guys, what you have to know is this. Here we do have this name. It is called what? MEP. It is called MEP BP. You see, ka? So this name MEP BP means what? M means it's meth. Then E, it is what? F. Then this P, it's prop. Then this B, it is what? But. Then this P, the last P at least, it's what? Pent. That's what it is. You see, ka? So the first member in all the families is what? It must start with myth. Then here, the second member, it must start with what? Eth. Then this one, it's prop. Then this one is but. Then the last one, it's pent. Like this. So here, the first member, I will call it as what? Methane. Take note, it's ending with this suffix. A-N-E, it like this one, ka? So this one is also ending with this one. You see the way it is, ka? Now here, guys, when you talk about alkenes, we do not have methane because alkenes, they start from ethene. All right? Alkenes, they start from what? Ethene. These ones, we do not have methane. They start from where? They start from ethene. Like this. Then this one, they start from the same thing. Here it will be called methanol, like this. Okay? Now they can ask you, to which group does methane belongs to? It belongs to a group or family called what? Alkanes. To which group does ethene belongs to? it belongs to a group, or be it a family called what? Alkenes. To which group does methanol belongs to, or family? It belongs to a family called what? Alcohol. Then now here, this one, it will be methanoic. Okay, saying something or saying a compound which has noic, like this, you see, methanoic what? Acid. Like this, take note. To which group does it belong to? It belongs to a group or a family called what? Carboxylic what? Acid. Okay, are we together concerning this part? Take note, in alkenes, we do not have methane. It starts from ethene. All right, take note. I will explain down. How is it? How is it here? Take note that in organic chemistry, we have four families. We do have the family of alkanes, we do have the family of alkenes, we do have the family of alcohol, we do have the family of carboxylic acids. Then now we have alkanes, okay? We have alkenes, we have alcohols and carboxylic acids. I hope something has been grasped here. I hope something has been grasped. Take note, guys. Here, it's meth. Then the second one is eth. So here, the second member in our cans, it will be what? Ethan, like this. Take note, it's ending with this. Then this one, it's what? It's ethene. It's ending like this. Then this one, okay, this is the same ethene, right? Then now this one, it is what? Ethanol, like this. Then this one, here it will be called what? Ethanoic. Here it will be called ethanoic what? It will be called ethanoic acid. You see the way it is, ka? So now here we continue. This is myth, eth, then prop. Okay, so here what we're going to do, the third member here is what? It's propan. Then here it will be called what? Propene. Here it's propene, you see. Then here it will be called what? Propano. Take note, all alcohols, they do end with what? No. Then what about this? It will be called what? Propanoic acid. This one will be called propanoic, like this, then acid. Like this. This is how you get right. Then the fourth member is what? It's but, which means butane. Then here it will be called butene. Here it will be called butanol. Then here it will be called what? Butanoic. It will be called butanoic what? Acid. Here it will be called butanoic what? Acid. That's what you have to know and also understand. Then the fifth member is what? Pentane. Then here we have pentene. Here we do have pentanol. Then here we do have pentanoic. We do have pentanoic what? Acid. So that's what we're having. So this is the family. Then the family, we do have a family of four: alkanes, alkenes, alcohol, and carboxylic acids. Then now each family has members. Take note, like what we do, like what we normally follow here in Zambia: banda, 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 all right? Banda. So the family of alkanes, it ends with what? Than, than, okay? Than. Take, check. Everything at the end is one and the same, all right? Everything at the end is the same. Also here, everything at the end is what? Is one and the same. It's ene, ene, all right? Then now here, alcohol, all right? It's ending with what? No, 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 and also here no, and also here no. Carboxylic acids ending with noic, 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 and also noic. All right? So these are the members. That's what we're having. Then now, here, it is very much essential after knowing these things, like what we said, that we have MAP, we have MAP BP. So from the same MAP BP, like what we said, meth, the first member, meth, starts with meth. Meth means what? It contains one carbon atom. it contains one carbon atom. So meth means one, okay? Then eth, okay, means what? It contains two carbon what? Two carbon atoms. That's what we're talking about. Then P, it is number 3, which is prop. Simply means it contains three carbon what? It contains three carbon atoms. Then now but, it means number 4. It means it contains four carbon what? It contains four carbon atoms. You see? So B, which is but, like this. Then the last one, which is pent. So pent. It means what? 5. It contains 5 carbon what? Carbon atoms. That's what we are talking about. So this is what you should know and also understand. Now, I do have these questions before we even go any further. I do have this question. So number 1, to which group um, do the following do the following belong? All right. So to which group do the following belong? Number 1, I am having ethene. The number 2, I am having propano. The number 3, I am having butanoic acid. The number 4, I am having pentane. What is the answer here? To which group does ethene belong to? To which group does propano belongs to? To which group or family do butanoic acid belong to and pentane? What are the answers here? All right, so Mola saying alkenes. Number 1, it's alkenes. Yes, that's correct. What of number 2, which is propano? To which group do they belong to? Okay. The number 2, to which group do they belong to? Okay, alcohols, that's perfect. Mhm. Then the other one for butanoic acid. Okay, butanol is alcohol, that's perfect. Okay, yeah, it's carboxylic acids. Yes, butanoic acid, carboxylic acids. What of the last one? Pentane, which group? Okay, you can see we are following. Okay, yeah, I have seen that you guys, we are together. All right, now, after knowing this, it is very much essential that we do the following things. And congratulations, guys, you have gotten it. Now, guys, after doing this, guys, like what we said, that we do have a family of alkanes, we do have a family of alkenes, we do have a family of alcohol, and we do have a family of what? We do have a family of carboxylic what? Carboxylic acids. Okay. Now they can end up asking you a question here that which family here, which family is also called paraffin? Which family or group is also called paraffin? So take note, alkanes are also called what? Paraffins. Okay? So alkanes are also called what? Paraffins. Okay? These alkanes. So these alkanes, they can also be called paraffin. So they can even ask you a question. Name a group or a family which is also referred to as what? Paraffins, especially in section A. Okay, which family is also called paraffins? It's alkanes. Then these alkenes, what you have to know, these alkenes are what? Unsaturated. Okay, alkenes are unsaturated. Unsaturated meaning what? They have a double bond. Meaning what? Double bond. So the word unsaturated simply means what? Double bond. This is what it is. So this is the only group which has a double bond. Okay? Alkenes, it is the only group which have a what? A double bond. That's what you have to know. Alkanes are also called paraffins. Then alkenes are unsaturated, meaning what? They do have a double bond. Meaning what? Here, upon drawing these masses, all right, you will end up seeing something like this. Okay? They do have a double bond which appears to be like this. Okay? So these ones are just way too straightforward. These, they do not have a double bond. They'll be just like this. You see, these ones, they have a double bond. Why? Because they are what? They are unsaturated. Okay? So alkenes are unsaturated, meaning what? They have a double bond. Then now, when you talk about alcohols, these alcohols, they just have a single bond like this. Also, these ones, they will be like this. Okay? This is what you have to know and also understand. Okay? I hope something is gotten here. I hope something is grasped. Are we together concerning this part? So alkenes are the only family or group which have a double bond like this. So whereby if they draw a structure, then now if you see something like this on the same structure, just know that it is an alkene. All right, because alkenes are the only ones which they do have a what? A double bond. Alkenes have a double bond. Is it okay, guys, concerning this part? I hope something has been grasped here. I hope something has been grasped. Okay. Now, when you talk about alkanes, okay, we also have what we call functional group. We also have what we call a functional what? A functional group. We have what you call a functional group. You see, we have what you call a functional group. So the functional group simply means, in simpler terms, what normally helps you to know that this is an alkane. So if you check, all alkanes, they end with what? ANE. So this ANE, it is simply the functional group of what? Alkanes. What has helped you to identify the what? The same structure, or be the compound. So this one, the functional group is ENE. You see, what is what is helping you to identify it? That's the functional group. Then now, the functional group of alcohol, it's what? It's negative OH. This is the functional group of alcohol, because all alcohols, they do end with what? They do end with what? Negative OH. You are going to see when you start drawing my structures, all right? Then now the functional group of carboxylic acid, it's like this. They do have a C, then here a double bond which is up here, even though it's not a double bond must be down like this. Okay, so its functional group, it's like this. It's like this. You see, so this is the functional group. All carboxylic acids, they do end like this. Okay, then alcohols, they end like this. We know concerning the part of alkanes and alkenes. So this is what you have to know. So this is the functional groups, all right? So these are the functional what? Are the functional groups that you have to know. Okay, now here, after doing this now, it is very much essential that you also know this part. I hope something has been gotten here, guys. Are we safe concerning this area? Are we safe concerning this part? Are we safe? All right. Interesting, Alaska. All right. Now let us start. Here, what are we going to do? After doing this kind of stuffs, what are we going to do in this case? Now, we have also to understand something. We also have this term which we have to know and also understand. So before we start talking about the term, you have also to understand that each family has a general what? Has a general formula. Each family has a formula that it follows. All right. So now here, now what you have to know is that each family has a general formula. So the general formula for all our cans, it goes like this: CnH2n plus 2. So this is the general formula for all our cans. Okay, even though it's way too straightforward, I will show you a simplest way. Okay, then now alkenes, the general formula is CnH2n. Take note, guys. They are just one and the same. CnH2n, also here CnH2n. Okay, they just differ at last. Okay, they just differ at last. These the alkanes, they are V2, but the alkenes, they just end from here. Then also these ones, it's CnH2n. For alcohol, okay, then here for alcohol, they do have a plus what? A plus one. Okay, these for alcohol, they do have a plus one what? OH. Okay, they do have what? Plus one OH. Take note, the functional group, it's what? It's OH. Now, what about these ones? It's still CnH2n, you see, plus what? Plus also one, this one, still just one and the same, plus one, then at last it's COOH. So this is the general formula for alkanes, the general formula for alkenes, the general formula for alcohols, the general formula for alkenes. Take note, these they do have plus one. Okay, these they also have plus one. Okay, there is no other name for alcohol. All right, there is no other name. All right. Yeah. Okay, another question. So what about those having okay, these are called carboxylic acids. All carboxylic acids, this is their functional group. This is how you can know them. We are going to look, we are going to go through some questions. You see what I'm talking about. All right. Now, this is how they do end. Okay. This is the carboxyl group, all right, which means the functional group for all carboxylic acids. Then now here, this is the functional group. This is the general formula. It has a two. They are all starting like this. This is the same. This is the same. This is the same. But for alcohol and carboxylic acids, they do have a plus one. Then here, don't forget alcohols, it's OH. This one is COOH. This is how you can do. You can know them. You see? Then now we are going to the part of drawing structures so that we see how we can draw. You see? Then now here the question is like this. Draw draw the draw the structure draw the structural formula draw the structural formula of draw the structural formula of the following. Okay, it's just one and the same. Alkanos or just alcohols is simply one and the same. So draw the structural formula of the following. So draw the structural formula of the following. So here we do have the likes. So draw the structural formula of the following. So draw the structural formula of the following. So here we do have methane, Then we do have um, ethene, and we do have what? Let me say propanol, and we do have what? Let me say we do have butanoic what? Acid. You see, ka? So draw the structural formula of the following. So we do have methane, we do have ethene, we do have propanol, and we do have what? Butanoic what? Acid. So this is what we're having. So take note here, they're saying that we should draw. We should draw the structural formula. So what are you going to do in order for you to start drawing? First, identify. Here, if you check, it is ending with ANE. This one is ending with ENE. This one is ending with no. This one is ending with what? Noic. Now, if I may ask, to which group does methane belong to? To which group, guys, does methane belong to? To which group does methane belong to? To which group does methane belong to? Yes, Mola. And Munyinda George. Yes, it belongs to a family called what? Alkans. Take note here, they are saying that we should do what? We should draw. Okay? Take note, they are saying that we should draw. What are we going to do? What are we going to do in this case? They are saying we should draw. So here, what are we going to do? So solutions or be the answers. So here, this is methane. So you write the same methane like this, you see, ka? You write methane like this. This is methane, right? So now here, methane, it belongs to a group of what? Alkanes, or the family of alkanes. That's what you should know. Now, what are we going to do in this case? Alkanes or alkanes, they do have a general what? Formula. What is the general formula for all alkanes? It's what? CnH, then 2N plus 2. This is the general formula for all alkanes. Take note, they do have a plus 2 here. All right, I will also show you the simple way. All right, so I will start first with the formula way. So it's CnH2n plus 2. You see, ka? Take note, guys, here, like what I said, that myth, it means what? It means 1. Okay, it means 1. This myth, it has what? 1 carbon atom. Myth has 1 carbon what? Atom. This is what it means. So myth has 1 carbon atom. So what are you going to do? On the formula, this C, the C you are seeing stands for carbon. All right? This C you are seeing stands for carbon. Then N stands for number of carbon atoms. The N which you are seeing on the formula here, this N, you see, N stands for what? N stands for number of what? It stands for number of what? Carbon what? Atoms. It stands for number of carbon atoms. So if you check, here we are having an N and also here N. Okay, so this N, where there is N, we will be replacing a 1. We will be replacing a 1. So where there is N here, you will be replacing a what? A 1. Okay, so we end up saying C. Where there is N, we end up putting what? A 1. Why are we putting a 1? Take note. Here it's what? It's myth. Myth, which means what? 1. Eth, it means 2. Prop, it means 3. Built, it means 4. You see, ka? Then paint, it means what? 5. This is what it means. Like what I've said, master this, map BP. You see, ka? It's map BP. Map BP simply means number 1, number 2, number 3, number 4, number 5. So where there is N, when you see something is starting with myth, where there's N, put 1. Where there's N, put 2. Prop, where there's N, put 3. Built, where there's N, put 4. Paint, where there's N, put 5. Guys, are we enjoying? 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 So where there's n here, I will end up saying this, open bracket, 1, like this. Then h2, where there's n, we also put 1, like this. Plus what? Plus 2. You see, this is what you should do. All right? That's what you should do. Way too simple and way too straightforward. So I will show you two methods, then you pick the one which is way too simple. All right? I will show you two methods so that you pick the one which is way too simple for you to do what? To do. Now, guys, what are you going to do? We all know here that C times 1, it is a C. It's more like in mathematics, we normally say that, okay, any letter in mathematics stands for what? Stands for 1. So we end up saying C times 1 is what? It's C. So C times 1 is C. Here it's more like we're saying C times 1 is C. Okay? If we had 2 here, we would have written C2 like this. You see, now here C times 1 is just C alone. So we end up writing the same H like this. 2 times 1, it's 2. You see, this is 2. You see, now here if we check, I've said 2 times 1, it's 2. We have what? Plus 2. You see, you see what I've written. So here, my final answer will be CH 2 plus 2. It is what? It is 4. You see, so here 2 plus 2, that's 4. You see, so this is the molecular formula. We are going to use this structure in order for us to draw. So the name of this answer, it is called what? It is called the molecular. So the name of this answer, it's called the molecular formula. We are not yet done, guys. They have said draw. We should draw. Guys, you cannot draw minus you finding the molecular formula. You have first to find the molecular formula, then the answer of the same molecular formula, that's what you're going to use in terms of you when it comes to drawing. You cannot just go directly. First, you have first to find the molecular what? Formula. So what are we going to do? Take note, guys, we have C. This C must be here on the middle. Pakati hapa, you see, how many H do we have? How many H do we have? We have 4. So here, the H must surround what? C. Also here, the H must surround what? C. Like this, this is what you should do. Then you end up getting 2 marks. You see, this is what you should do. So this is method number 1, or let me show you also method number 2. Okay? Method number 2 goes like this. Take note, myth, all right? Myth. Okay, so before I even show you, let us also try this one. Ethan, you see, for Ethan. Okay, like what I've said, guys. Myth means 1. If means what, guys? If, like what I've said, before you start drawing, look at the first what? Look at first the first letters. Here it's if. If means what? It means 2, right? It means 2. That's what it means, right? That's what it means. It means 2. So what are you going to do? Here, we all know that it's CN H 2 what? 2N plus what? Plus 2. All right? So what are you going to do? Where there's N, we will be putting 2. All right? So it's C. Where there's N, it's 2. Then H, you see, 2. Then where there's N, we end up putting the same 2 plus what? Plus 2. So it's C2. Then we have H. 2 times 2, it's 4. 4 plus 2, it's what? It's 6. So here, take note in mathematics, when you have a number outside, then you do have brackets. We do times, all right? So we say 2 times 2, that's 4. You see, that's what I've done here. 2 times 2 is what? 4. Then 4 plus 2. You see, that's what? That's 6. You see, this is the what? This is the molecular. You are not done. Now draw. You simply take note the C's must be in between. Start with the C's like this. No wonder organic chemistry is the study of carbon atoms. The C's must be in between. Then surround the C's with how many H? How many H? 6H. All right. This is what you should do. Like this, how many? 1, 2, 3, 4. So we are remaining with the other ones so that they are complete. So 1, 2, 3 here, 4, 5, 6. We are done. Okay. How is it, guys? Can we manage to draw some structures? Can we manage to draw structures under alkanes? Can we manage to draw structures under alkanes? Mhm. All right. Now, if we check, now here, guys, let me also show you a tricky. Let me show you a tricky one, a tricky method. All right. Let me also show you a tricky method. Take note, it says methane. Okay. All alkanes, all right. All alkanes, all right. Everything which involves alkanes, all right. You can simply do this. Okay. So when you talk about alkanes, anything which involves alkanes, all right. So like what I've said, the first member in alkanes, it's what? Methane. So methane, its molecular formula, it's what? CH what? 4. So methane, its molecular formula, it's CH4. You see, ka? Then now, what follows? It's ethane, which means what? 2. Its molecular formula. Then also this one, we have propane, and also we have what? We have the number fourth one, which is butane. Then the number fifth one, which is what? Pentane. Guys, don't forget the name MAPBP. MAPBP. All right. So what are we going to do here? Guys, here we know that, okay, methane, its molecular formula, it's what? CH4. So what are we going to do here, guys? How many C's do we have here, guys? How many C's do we have here? How many C's do we have? We have two. Huh? Are you sure? How many C's do we have here? When it comes to the molecular formula for methane, how many C's do we have here? How many C's? It's one, right? We have one C. So what are you going to do? It's way too simple. You end up saying, since this is one, this is what? Two. You see, ka? Then this one is what? C3. This one is what? C4. Then this one is what? This one is C5. You see, ka? Okay. So here we have one, which means myth, two, which means if, three, which means prop, four, which means but, five, which means pent. You see, ka? Now, here, when it comes to H, you see, ka? H here, H, also here H, and also here H. Now, here we'll be adding plus 2. So 4 plus 2, it's 6. 6 plus 2, it's 8. 8 plus 2, it's 10. 10 plus 2 is 12. That's all. That's what you should be doing. So here we are adding plus what? We are adding plus 2. Here we are just continuing. It's C2, C3, C4 up to C5. So here we will keep on adding 2, keep on adding 2. Okay? So in short, you can simply cancel this formula. If you feel like you are facing challenges when it comes to remembering this formula, you can cancel it. Follow this one, you can follow this one, okay? If you feel like this formula is big for you, you can simply use this one of just starting like, okay, they want me to draw propane. Just start methane. Methane is what? CH4. Remember the first one that is CH4. Then now start C2, C3, C4, C5. Okay? Okay? Then now here it's what? C4. Then here you keep on adding plus 2, plus 2, plus 2, plus 2 in what? In alkanes. In alkanes, that's what you have to know. If this formula, you are facing challenges with the formula, all right? If you're facing challenges in terms of what? Knowing this formula, you can use this trick. It's going to help you, okay? Now, the other question says what? we should draw the structure of ethene. The other formulas, the other question says that we should draw the structure of what? Ethene. I hope this is helpful, guys. I hope this is helpful also. If you feel like this formula, you can forget it, you can end up writing something wrong, you can use this one trick, okay? You can use this trick. I don't know between the two you are going to choose, all right? Between the two you will choose. Okay? You can choose between the two. Is it okay? 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 Between the two? All right. Okay, perfect. Now, here they are saying that we should draw the structure of what? Ethene. Like what I've said, guys, draw the structure of ethene. The first key thing, look at the first one, it's eth. Then the last one is what? Ethene. Guys, to which family or to which group does ethene belong to? Name a group or rather a family to which ethene belongs to. Which group does ethene belong to? Actually, it's a member. Now, to which group does it belong to? So Vasco saying alkenes, Mola saying alkenes, Alaska, and also almost everyone saying alkenes. That's correct, guys. This, it belongs to a group which is called what? Alkenes. That's correct. It belongs to a group which is called what? Alkenes, because it's what? Its suffix, it ends with what? ene. It belongs to a group which is commonly known as what? Alkenes. Okay. Now, here, alkenes, they do have a general formula of CnH2n. The simplest ever. The general formula, it's like what? This. That's what you have to know. Now here, guys, like what we said, if, if, if means what? It means two. Simply means where there is n, we will be putting two. Here we put a two, then h, then two. Where there is n, we also put two. So here, where there is n, I have put two. This is h2, part of the formula. Then where there is n, I have put two. So what is the answer? C2 H 2 times 2 is what? It's 4. So you're not done. This is the molecular formula. Now we are going to use the answer for the molecular formula in order for us to draw the structure of ethene. So what are we going to do? We are going to start first with the C's. So it's C and also here a C. You see? Now guys, let us be careful a bit. Like what I've said, all alkenes, they have a what? They have a double bond. Alkenes, they do have a what? A double bond. Alkenes, they do have a double bond. So you must not write like this. You see, ka? So put another double bond like this. You see, ka? Also put another double bond like this. It is the only group which has a double bond. So what are you going to do? How many H? It's 4. So here, like this. You see, ka? Also here, like this. You are done. You see, ka? So here we have 1, 2, 3, 4. You see, ka? This is how we get to write them. I hope something has been grasped. Another example also, I hope we are moving together, guys. Also, I have given this one. Let us also try this one for propene. I hope we are moving together here, guys. Is it okay? So is it okay when it comes to this part? Is it okay? Is it okay? Is it okay? Take note, alkenes, they have a double bond. It is the only group which has a double bond. The rest, they are just saturated. All right? But these ones are unsaturated. So let us try for propene. What are we going to do? The same thing. They have a general formula of what? CnH2, then what? N. So this is the general formula. So guys, prop, prop. Prop means what, guys? Prop, prop, it means what? Okay, interesting, guys. What does prop means? What does prop means? So when you talk about prop, it means what? Prop, 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 prop. Yes, it means 3, right? Thank you, Kelly. All right. 3. Congratulations. 3 carbons, right? That's what it means. So where there's N, we should start putting what? We should start putting 3. So here where there is N, then also here H2, then where there's N, we put what? A 3, like this. This is how we're going to do it. So now we start. It's C3. 2 times 3, what is the answer? It's 6. So this is not your answer. This is just the molecular what formula. We are going to use the same molecular formula in order for us to come up with the what? With the structural what? Formula. So what are we going to do? How many C's are we going to write? 3. So it's 1, you see, then 2, then what? Then 3. This is what you're going to do. You see, guys, then now you are going to choose where the double bond will be. You are going to choose where the double bond is going to be. All right. If you want, you can put your double bond here. And also, if you want, you can push the double bond here. But only put once, all right? You cannot put here a double bond and also here a double bond. A double bond must be just be once, all right? Like this. We have Sika, we have these. If you want, you can push the double bond here. If you want, you can put the double bond like this. The double bond can be here, okay? So this is what you should do, okay? So you can choose, all right? So choose where the double bond will be. Are we safe here, guys, concerning this part? Are we safe concerning the part of choosing? So here you do have a choice. If you are having more C's here, you see, here we had 2. No wonder here it was just in between. But if you are having more C's like this, pick, choose where the double bond is going to be. You do have a choice. You do have a choice where the double bond is going to do what? To be. You do have a choice where the double bond it will be. Are we safe here, guys? Concerning the part of picking where the double bond will be. Uh-huh. Are we safe? Have we gotten the point when it comes to picking or rather choosing where the double bond will be? You see? Yes. Now, here, if you want, you can put it at first. If you want, you can put it at last. Okay? I have put it here. You see? How many H? You see? 1. Even this side, you can say 2. You say 3. You say here 4, 5. Then what? If you want, it can be up or down. It's up to you. Then 6. Then you are done. So 1, 2, 3, 4, 5, then 6. Then you are done. Okay? So if you are having more than 2 bonds, okay? If you are having many C's like this, make sure that the double bond must breathe. Okay? When you are having more C's like this, you must not cover the double bond with H's. Don't do like this. Okay? Don't do like this. Okay? Like this. If you check, like the way it is, like the way it is, here, like the way it is. Okay? You must not do like this. You must not do like this. You see, you must not do like this. I hope something has been gotten here, guys. When you are having more C's, C, 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 when coming up with these H's, you must not cover, okay? At least one side it must breathe, okay? At least one side must what? Must breathe, okay? So here, the other one, so that we talk about propano, butene. Let us try also for butene. We all know that butene is 4. So it's CnH what? 2n. Where there's N, it's what? 4. Then H what? 2. Where there's N, 4. What are you going to do? CH what? C4. H 2 times 4, it's what? It's 8. Let us draw the structural formula. How many C's? 4. 1, 2, 3, then 4. You see, so what are you going to do here? You can pick, if you want the double bond can be here, or there. If you want, you can put it in between like this. You see, if you put it in between here, guys, take note that these C's, the 2 C's which have a double bond, you must not cover them with the H's. So you simply do this. You simply say 1, You see, you simply say 2, okay? You simply say 3. That's all. The other part must breathe. If you are having more C's like this, okay? Only for 2, this one, okay? You see, these 2 C's, they have a double bond. But if you're having 3, 4, 5, if they keep on increasing, all right? That's where now you can do this. You must not cover this double bond with what? With the H's. Then now here we have what? 1, 2, 3. Then they want what? H. So what are we going to say? So 1, 2, 3. Then we have what? 4, 5, 6, 7. Then what? 8. Like this. This is what you can do. If you want the double bond can be here, take note, H, H, H. The other side must breathe. This is what we are talking about. So where you have put a double bond, make sure that things are what? Things are one side must breathe. I hope something has been gotten here. I hope something has been gotten here. I hope something has been gotten. So you do have a choice to pick where the double bond is, but make sure you must not cover the 2 C's which have a double bond with the H's. Let the other side breathe. Okay? Okay. Thank you very much. Now we move to propanol. So we have what? We have propanol. You see, we have propanol. Guys, propanol. To which group does propanol belongs to? To which group does propanol belongs to? Yes, congrats guys. Propanol, it belongs to an interesting group, which is no other than what? Alcohol. Take note, its suffix, it's ending with what? With no. It's ending with what? With no. So let us draw the structure, okay? Let us draw the structure. It's like this. Then now here we have what? The general formula, CN, take note, CnH2n is just the same here. Take note these, they do have a +1, the functional group OH. So this is the general formula for all what? Alcohols. Alcohols, they do have a +1, and also carboxylic acids, they do have a +1. All right, that's what you should do. Now let us start. Prop. What does prop mean, guys? Prop, it means what? What does prop mean? What does prop mean? What does prop mean? Prop, Mola saying 3, Alaska saying 5. Are you sure? Prop, it means 5. Okay, Chi Chi saying 3, that's correct. Prop, it means 3. 3 carbon what? Atoms. So where there's N, let us start putting a 3. So here a 3, then H2, where there's N, we put a 3, like this. Plus what? 1. Okay? Sir, the carbon should surrounded with 4. Sir, the carbon should be surrounded with 4 carbon hydrogen only. Okay, like it's only for what? It's only for ethene. Okay, like for example, if we are having C, if you find your molecular formula like this situation, that's where now you can cover like this. You see, you can only cover if the C's are just 2. Kyrie here is just what? The molecular formula is C2H4. How many C's? There are 2. 1, 2. Then how many H? 4. So it's C, double bond C. Then you do H, 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 which means 1, 2, 3, 4. It's only for 2, but for 3, 4 going up, take note, you pick, you choose where the double bond will be, but make sure, like for the instance, for this one, you see the way it is, you are going to pick where the double bond will be. Let us assume that it's here. Make sure you do H and also here, H and also here, H. Don't put an H here because of what? We are having more than. The other side must breathe, so you come to this side like this. Also here, like this. Also here, like this. So this part must breathe is only for 2. I hope this part has been grasped. So plus 1, then OH. So we have what? C3, 2 times 3, which is 6, plus 1, 7. So we have H7, OH like this. This is what you're going to do. You see, ka? So this is the molecular formula. Let us draw it. How many C's? We have 1, 2, 3. Here we do not have a double bond, guys. It's only in our alkenes. All right? It's only in alkenes. Alcohols, carboxylics, they do not have a double bond. Okay? Take note. How many C's do we have? We have 3. So 1, 2, 3. Have you seen where this OH is? Put it at last here, like this. This is what you should be doing. So after writing the number of carbon atoms, do minus, then OH. To show that this is the functional group, this is what will help you to do what? To know. Then how many H do we have? 7. So it's 1, 2. Don't count this H, all right? You must not count this H. This H, it is together with O, okay? It is together with H or the negative. It's a functional group. It's the one which will help you to know that this is alcohol. You see, like this. This is what you should be doing. So how many? We have 1, 2, 3, 4. Then here we have 6. Then here we have what? 7. Like this. Then you are done. Have we gotten something here, guys? Is it okay concerning this part? Okay. Is it okay concerning this part? Take note, all alcohols, they do end with no, 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 no. This is how you do them. All right, perfect. So this is how you get to do them. They're just way too simple. Then now we do the last one for what? For Atikashi, was simple. Yeah. The problem is that you end up thinking as if organic chemistry is hard. It's way too simple. All right. You thought that it was hard. Now you are learning. Huh? Yes. You do have Mr. Bright. All right. You do have Mr. Bright Mlekwa tutor. All right. Where learning becomes like a you'll be learning like a baby. All right. You will be learning like a baby. If you do have friends, all right, if you do have Alaska, you can kindly tell them, all right, you can simply tell them. Actually, Alaska is one of my students here. He's a physical student here. We normally see each other daily, all right. We normally see each other daily. These guys, they normally come to my place. This is where I normally do my tuitions from, all right. So that's what it is. And guys, if you do have relatives who will be sitting for next year's examination, GCE, you can simply invite them, all right, saying that, okay, there is Mr. Bright here, so that you clear your science, all right, so that you clear your science. If it's for English, yes, it's a bonus, all right. Yeah, our HOD, that's true. So for butanoic now, we have butanoic acid. I do have a question here. Butanoic. To which group does butanoic acid belong to? To which group does butanoic acid belong to? To which group does butanoic acid belong to? Who can name the group to which butanoic acid belong to? Yes, Vasco. Yes, correct. It's carboxylic what? Acids. This belongs to carboxylic acids. Take note, they are ending with noic. They are ending with noic. All right. They are ending with what? Noic. So they are ending with what? They are ending with what? With noic. That's what you should be doing, or rather knowing, all right? So here, what of but? Bute means what, guys? Since you have known that, okay? Since it ends with noic, it belongs to carboxylic acids. What of bute? It means what? How many carbon atoms does it have? Mhm. It means four, right? Yeah, perfect. It means four. It means four carbon what? It means four carbon atoms. That's what you are trying to say. That's what you are trying to break down. To break down. All right. So bute means four. Vasco, not three. All right. It's four. Don't forget MAP BP. All right. So here, what are you going to do? The general formula, it's CnH2n plus what? Plus 1. COOH. All right? COOH. Okay? So here, what are you going to do? We start. Bute means what? 4. Where there's N, we put 4. So it's C. Where there's N, we put what? We write 4. Then H, then what? 2. Where there's N, write 4. Then plus what? Plus 1. You see, ka? Then we write the same COO what? H. So here we're going to say C4. 2 times 2 is what? 2 times 4 it's 8. 8 plus 1 is what? 9. So it's H9 COOH. You see, ka? So this is the molecular formula like this. So this is C4. This is C4. Then 2 times 4 it's 8. Then plus 1 which means 9. Then here we write like this. You see, ka? So here, what are we going to do? We are going to do this. If you check for over here, guys, start with the C's like what we are doing. We are going to say 1, 2, 3, then what? 4. Okay. Now, guys, take note. This is the what? The functional group. This is the functional group. That's what you have to know and also what? Understand. This is the functional group. This is the functional group. Like what we are saying here, guys, take note. We were saying what? Myth. Myth means what? 1. Eth means 2. Prop means what? Means 3. Then pute means what? 4. Then, okay. You are surprised you're understanding everything, huh? We are gifted in terms of teaching, all right? Yeah, we do. We are gifted. All right. So here, guys. So myth, eth, prop, pute, then paint. You see, huh? So in alkanes, in alkenes, and in alcohols, you see, huh? Guys, in alkanes, in alkenes, in our alcohols, we do follow these, ka? We have followed these. We were following these, ka? You see, ka? This is what we were following. You see, ka? Saying that myth, it means 1, eth, it means 2, okay? Prop means if we have more than 5, it's hex, but in most of the paper, hex, hex means what? 6. But in most of the papers, they just end mainly on number 5. All right. So we can continue. Hex, which is number 6. Now, guys, like what we are saying, huh? Alkanes, alkenes, and alcohols, right? We were saying that myth means 1, eth means 2, prop means 3, bute means 4, paint means 5. This is what we were doing, isn't it, guys? This is what we are doing, right? That in alkanes, okay, myth, this is what we are doing. So, guys, that's what we are learning, right? That's what we are doing, right? We are doing this kind of stuff, right? This is what we are doing, right? Isn't it? This is what we are doing. Okay. Now, this is what we were doing, isn't it? Yes, we were doing this. Then now here, what you have to understand, we have three groups here, guys. We have three groups. We have alkanes, okay? We have alkenes, we have alcohols. Then now the other group here, when you talk about carboxylic acids, okay? So we have carboxylic what? Acids. Now, in carboxylic acids, things they do change. In carboxylic acids, things they change. You see, now here, like what we are saying what? Myth. Okay? Myth, it means one, but here in carboxylic acids, it starts from zero. So if means what? Means one. You see, then prop, it means what? It means two. So carboxylic acids, myth is zero. It's the only group which is like this. But the rest is just 1, 2, 3, 4, 5. But carboxylic acids, they start from 0, then 1, 2, going down. So bute, instead of 4, it will be 3. You see, then now here, this one, it's pent, it will be 4. You see, it is the only group whereby we are going to start from 0. Okay, so it is the only selfish group whereby it starts from 0. 0, 1, 2, 3, 4 is the only group, all right? Yes. Why do we start from 0? Because it has a C already. Check. It has a C already. It has the C already. Okay. It has an extra C already. Okay. So what we're going to do? The delay doesn't even cancel this one. The delay doesn't even cancel this one. I was trying to explain here. So we do this. The one for what? For butanoic. You see? For butanoic acid. You see? So but we all know the general formula is CnH2n, then plus what? Plus 1 COOH. What are you going to do? Take note, guys. But. They have said butanoic what? Acid. But. Now, since it's a carboxylic acid, what are we going to do? All carboxylic acids, they start from 0. So it's 0, 1, 2, 3. So here, butanoic acid means what? Means 3. Or what you can do, you can simply do this. Since you know that but, it means 4, you can simply say this. 4 minus 1. What is the answer? It's 3. Okay, so once they say begin, let me say propanoic, you simply say, since you know that the prop it's what? Prop it's 3. You say 3 minus 1. You be just doing 3 minus 1, then that's 2. Okay, because here we are going to have 3. Since I know that this is 4, this is 4 minus 1. You will be doing minus 1. This is 3. Okay, or if you want, you'll be doing this. Okay, you say 0, 1, 2, 3, like this. You choose between the two, the one which works faster. Okay, so we have C, where there's N, it's what? 3. Then H, 2, where there's N, 3. Then plus what? 1. COO what? H. You see, then you start C3, 2 times 3, which is 6, plus 1, 7. Like this. COO what? H. Like this. This is what you do. Are we safe here, guys? So you can pick the one which is more simpler for you. If you see that it's but, you know that but is 4, you say 4 minus 1, that's 3. You put 3. You say prop. Prop, you know that it's 3, you say minus 1, then which is 2. Do like this. Or if you want to do this, you come up with this. You end up writing this. Okay? You end up writing this. Okay? Okay, like what I've said, that carboxylic groups, it is the only group which starts from 0. Alkanes is simply 1, 2, 3, 4. They will be starting from 1, 2, 3, 4. Alkanes 1, 2, 3, 4, 5. Alkenes 1, 2, 3, 4, 5. Alcohols 1, 2, 3, 4, 5. But carboxylic acids, they start from 0. It is the only group which starts from 0. Why? Because it has an extra C already. I think there's no need to even to start explaining here. These carboxylic acids, they start from 0. Okay, they start from, it is the only group. One seeing butanoic acid. Take note that this is what? A carboxylic acid. What should you do? what you do, you know that built, it means 4. Just say 4 minus 1. What's the answer? 3. Put 3 without even coming up with this. You see, ka? So which one is more simpler between the two? Is it the first one, this first thing, or the second one? Between the two, which one is more simpler? Which one is more simpler? Is it the second one or the first one? Take note, all carboxylic acids, they start from 0. That's what you have to know and also understand. All right, I hope something has been grasped there. Yeah, so this is what you should be doing. Now let us start. Let us draw now their structure, C3. What are you going to do? It's 1, 2, then what? 3. You see, ka? This is what you should be doing. So C3, it means what? 1, 2, then 3. Guys, let us pay extra attention here. We have C3, 1, 2, 3. Now if you check, we are also having another C here, right? So after writing 1, 2, 3, connect. Here you say minus C. Where is this C coming from? It's coming from here. You see, so how many C's do we have? 1, 2, 3, 4. 4 means what? Butte. You see, we are still coming back. We are still coming back. We have also come back. So the main reason why we start, all right? The main reason why we start from 0, it is because we have an extra C already, okay? Because here on the formula, we have C already. So check, guys. We have 1, 2, 3. This is the what? The 3. Then we have the C already. So if I do 1, 2, 3, 4, it's butanoic still, it's beauty, which means 4. So this C, it is part of the formula already. I hope something has been grasped here, guys. Is it okay? Is it okay here? You see that we have an extra C already here. That's the main reason why we are starting from 0, so that upon adding it, we have 4 already. You see, so that's the main purpose. So that's the main reason why the formula is like this. It starts with 0, it starts with C or OH. The C, it will be added from what we have found. You see, that's what it is. Is it clear here, guys? Is it clear? So C3, these are 1, 2, 3. Then the C, this is the C. I hope something has been grasped here. Is it clear concerning this part? All right. Now let us come. Here, guys, I hope we have seen, at last we are having this. You see, what we're having? We are having COOH. That's what we're having. Now, this COOH, you must not write it exactly the way it is. You see, we are having COOH. Take note, this C, it is the C. Okay? This C here, this is the C I've written. I have remained with what? 1, 2. 2 O's. So this key thing, it can be written like this. It's what? C, you see, then you say a double bond on top like this, okay? Then O like this. You see, so this is C. This is the C. Then O. This is the O. Then here, take a linkage, then another O. You see, this is C. This is the C. O O. This is O O. Then you just write like this. H is still one and the same. You have seen, guys. So this is C. This is C. O O. This is O O. Then this is H H. You have seen, guys. Have you seen? It's still one and the same. Have you seen? Or you can write it like this if you want. It's your choice, all right? Here, take a double bond like this. It's your choice. You can say linkage, then O, you see, minus O. Okay, it's still one and the same. If you want, you can even separate this O minus O. You can even separate them. If you want, you can write it in this way, or if you want, you can write it in this way. It's still one and the same. So that's what you are going to do here. It's here like this. You see, like this. You see, then here like this. OH, or you can say O minus H. Okay. So this is the what? The functional group. So when you see a structure or a drawing which looks like this, take note guys, it is what? A carboxylic acid. It falls under carboxylic acid. And what is the name? It's butanoic. Why? We have four C's. We have one, two, three, four. We have four C's. Now let us start drawing H7. How many H should we have? 7. So one, you must not start from here. Take note, guys. This is the what? The functional group. So here, 2, 3, 4, 5, 6, then what? 7. Like this. You see, ka? So this is 7. Then you are done. You will end up getting 2 marks for free. I hope I've helped. Have I? Have I helped? Have I helped? Okay, so here, thank you. That's the rule. That's the rule that the carboxyl group, it must have a bond on top. That's the rule. Okay, that's the rule. All right, that's the rule. It's a rule that it must have a double bond on top. That's the rule. Okay, or in simpler terms, I can simply say the main reason why it is having like a double bond on top, it is because we are having two O's. I hope I have answered the other person. Like a double bond on top there, it means that, okay, we have two O's. We have O, then O. Okay, no wonder we have those two double bonds. It means that, okay, we have two O's, which are following each other. If you check, we have C, O, O, H. So these, the O's on in between, they are what? They are two. That's why we are having like a double bond two there. I've answered, right? All right. Impressive, guys. Thank you very much. Yes, I do have a WhatsApp group. Yes, I do have a WhatsApp group. Okay, so here, guys, let me do this. Which one? This O. This O, it's part A, is the functional group. Okay, the O is the functional group. Okay, it's the functional group. This one, you see, this is the functional group. It is simply indicating that this is a what? A carboxylic acid. It shows you that this belongs to a what? A carboxylic what? Acid. Okay, it is showing you, it's helping you. They can bring this structure which looks like this, then they ask you, name the group where this structure belongs to. It's a carboxylic group. Because of what? It has this. This is the functional group. What has helped you to identify it? If it ends like negative OH, we know that it's what? It's alcohol. You see, if it has a double bond, we know that it's an alkene. You see, okay. Have we seen how they brought? Have we seen how it is, guys? Yes, that's how it is. So yes, we are giving it a double bond on top because we are having two. We have two O's. We have one, two. We have this one and also two. That's why it's C and a double bond here. O. Why? Because we have two O's. Okay, that's what it means. This is what it means. O, O. This is what it means. The double bond. All right, let me try to look for a question whereby it's going to answer how far we have gone. Okay, I have found the questions. Now let us proceed a bit. Okay, I hope here it's clear, guys. I hope it's clear here. hope it's clear. Is it clear? Is it clear? Is it clear? Are we moving, guys? Are we moving so that we even do some polymers, then some esters, then we can even look at nanometals, then at least have helped. Okay. So to all those who are under my WhatsApp group, they're even sleeping as for now. Imagine, they're even sleeping. They are resting. All right, let me even drink some water. I'm coming. All right. Then now, here, it is very much essential now after getting one or two from that same part, we see how we can handle them. All right. For internal, are you an internal student? Are you an internal student? Are you an internal student? Let me look for the questions. All right. So, organic, a minute, guys. Let me look for the questions. Whatever we can do. Okay, a minute. Yes. Okay. Have you seen, guys? Here. Have you seen how it gets to come? Okay. Have you seen how it gets to come, guys? They're saying propene is one of the many important hydrocarbons obtained from crude oil. Like propan, it is made of molecules which contains three carbon atoms. Then draw a structural formula for propene. Can we manage, guys? Can we manage to get the marks there? Can we manage to draw the structural formula for propene? Is it hard? Is it hard? Can we manage to get the marks? You see? Then the other question is like this. How does propene differ from propan in terms of bonds? Yosika? How does propene differ from propan in terms of what? Bonds. You see, right? Okay. So at how does it differ? We have propene, which is an alkene, and propan, which means an alkane. So they do differ is that propene has a double bond, while propan has a single bond. That's the only difference here. Okay. Propene is an alkene. It has a double bond, while propan has a what? Has a single bond. All right. The number three, to which group of hydrocarbon does propene belong to? Guys, this is yours. Number three, guys, to which group of hydrocarbons? Okay. Yes, they do differ with the double bond, the same thing, because see, the propane, they do have the double bond, then propan, single bond. So, to which group of hydrocarbon does propene belong to? Alaska, alkenes, You have seen how it gets to come here. So this is how it gets to do what? To come. All right? Yes. Okay. So this is what we are talking about. Then now here, give the molecular formula for propan and propene. So they want the molecular formula, guys, not the general. They want the molecular formula. That other one, like C3H9, C2H what, that's what they want. The molecular formula. Mhm. So the first key thing that you have to solve in order for you before you even start drawing the molecular formula. We know that prop means 3. That's what you have to do. Okay. Then also for propene, take note this one. Okay, they just want the molecular formula for propan and also what for propane. Okay, like what we were doing here, guys. Okay, let me try to do so like what we are doing here, like CnH2n. Okay, for propene, you see, which means prop, which means 3. Okay, where there's n is what? 3. H then 2. Where there's n, 3. You see? So it's C3, then H what? 6. That's the answer they want. This is the molecular what? Formula. This is the molecular which they want. That's all. Then also they want for what? They also want for propan. They also want for propan. Like what I've showed you. Okay? Yes. Molar. Congrats. It's C3H8 without even solving. Yes. Without even writing the chemical formula. All right. So that's impressive. All right. So now here, that's how we should do it. Now, here guys, have you seen we can try to answer one or two, okay? Yes. Have you seen that you can try to answer one or two, okay? From the same from the first part which I've just go asked you, okay? You have seen, okay? You see, okay? Now imagine, just imagine if we were together starting from January. Imagine, guys, if we were together starting from January. Imagine if we were together. Okay. So here, something also very, very much important here, like this, something very much essential. Let me do this. Okay. Then also number 2 here. Then now here, they can also ask you a question. Okay. They can also ask you a question here. A question goes like this. Which compound, which compound have, which compound have the what? Which compound have the highest, which compound have the highest boiling what? Boiling point. Which compound between the two? We have number 1 and also number 2. Which one between the two has a highest boiling point? So the answer is number 1. Guys, the more the carbon atoms, the more the boiling point. All right? The more the carbon atoms, the more the boiling point. The longer the chain, the more the boiling points. Okay, that's what you have to know. Check. Here we have 1, 2, 3, 4. Here we have what? 1, 2, 3. They're going to ask you, which compound has the highest boiling point? Is this one because it has the what? The highest, the longer chain. Okay, so it's number one. Okay, which means because it has a what? Because it has a long chain, because it has a long chain of what? Because it has a long chain of carbon atoms. That's what you have to know. Okay, carbon atoms. Molecular formula is not the same. Molecular formula is the CHH thingy, okay? But the general formula is the one which we use, the CnH plus 2n plus that one, all right? So because it has a long chain of carbon atom, so the more the number of carbons, the higher the boiling point. I hope something has been gotten here. If you do have a compound which is having more carbon atoms, take note it is having what? The highest what? Boiling point. So this one has a lowest boiling point because of what? It has what? Least carbon number of atoms from this one. So this one has the lowest, this one has the highest. Is it okay concerning this part? Ehen. So this is what you should do and also understand. I hope something has been gotten. Then also this last one before we even do which which compound which compound so which compound react can react with what with steam. So which compound can react with steam? Okay guys, take note. Steam means what? Steam means water. The word steam simply means what? Water. So the word steam simply means water. This word which you are seeing here, it's water. So they're simply asking you, between the two structures, which structure can react with water? Which structure between the two can react with water? All right. So between the two, the structure which can react with water, okay, it's what? It's two. Okay. Take note. Alkenes, take note, these they do have a what? A double bond. So this double bond makes them to do what? To react with water. React with what? React with steam, which means water. Okay. So the alkenes, they can react with what? With water. Okay. That's what you have to know. Okay. So the alkenes, because of their double bond here, okay, they are capable of what? Reacting with what? With water. That's what you have to know. So they can say which compound can react with steam, or they can say which compound can react with what? Bromine. Okay, bromine what? Water. Like this, is simply one and the same. Okay, so the one which is capable of reacting with bromine water or steam is what? It's the alkenes because of their double bond here. I hope something has been gotten here. So these are some of the questions that they can simply ask you. All right. Okay, is it clear concerning this part? Yes, so the longer the chain, the higher the boiling point. If you're having more carbon atoms, take note, simply means we are having the higher boiling point. Right? Then now, the group which can react with steam, which means water or bromine water, it's what? It's alkenes. So this is the compound because of a double bond, all right? So I hope I've helped. Then now, we are about to talk about the polymers also, so that at least you do have a clue when it comes to those. Now let us start. Now here guys, when you talk about the same alkanes, so these alkanes, all right? So these alkanes guys, these, the group alkanes, all right? Alkanes are large molecules. That's what you have to understand. That this group, alkanes, they are large what? Molecules. Why are they large? Because if you check, most of their members, they are having big numbers. All right. Best example is for what? Let me say if you check, let me say here like what we said, CH4. So then we have C2H what? H 6. We have C3 H what? H8. To give an example, you see. So these they are having bigger numbers. If you check, we have bigger numbers. But alkenes, alcohols, and carboxylic acids, they're having smaller numbers, but these ones they have what? Big numbers. You see, alkanes, guys, they are large molecules, they are big. All right, they have large molecules. Their members, they are big. Okay, they contain large molecules. All right. So since these they do contain large molecules, what should we do them? We must break them. We must break. We must break them. We must break. Okay. We must break them. Since they do contain large molecules, they do contain members having the large molecules or the number of carbon atoms and also hydrogen atoms. What should we do? We should break them. Okay. So this process of breaking them, it is also called what? Cracking. Okay. They can also ask you, define what cracking is. So cracking, it is the breaking down of large molecules into smaller ones. Okay. Cracking. Okay. Cracking, that's what you have to understand. We can only crack the alkanes because these, they do have what? Highest number of what? Carbon and also hydrogen what? Atoms. So here, asking you to define what cracking is. So to crack simply means is to break. So cracking is the breaking, all right? Is the breaking of what? Is the breaking of large, okay? Of large what? Of large compounds or be it molecules, okay? Into smaller ones, into smaller ones. You see, this is what we're talking about, or into smaller molecules. You see, so cracking is the breaking of large molecules into smaller ones. Are we together here, guys? Like what I've said, alkanes, they are way too big, so they're supposed to be broken down. Now, the process by which they are broken down, it is called what? It is also called cracking. So define what cracking is. Cracking is the breaking of large molecules into smaller ones. Are we safe here, guys? Are we safe concerning this part? And also this, we do have types, which are just two. Asking you types, right? Types. Number one, we do have what you call thermo. They can ask you to name the types of how we can try to break down these molecules. We can use thermo cracking. Guys, take note. Thermo means what? Heat. So this one, it involves heat. All right? Heat. So the word thermo means what? Heat. So the first type of cracking is called thermal cracking, okay, which means heat cracking. Here, in order for us to start breaking, we must involve heat. So we can break these alkenes into simpler ones by using what? Heat. So the name of this cracking is called what? Thermal cracking. Okay. Then now we also have what you call what? Catalytic. Catalytic. Okay. Cracking. Okay. We have what you call the catalytic cracking. So this one, it involves a catalyst, just from the name itself. Okay. A catalytic. So this one involves a catalyst. take note, a catalyst, it normally helps in terms of what? Speeding up the reaction. So now here, a catalyst is involved, okay? And apart from a catalyst, also heat. So this one uses both the catalyst and also what? Heat. That's what we have to know about. Okay, so cracking is the breaking of large molecules into simpler ones or smaller ones. There are two types of cracking. There is what you call thermal cracking, which involves heating. Then now, number two, we have catalytic, which involves both a catalyst and also what? Heat. That's what we should know and also what? Understand. I hope something has been grasped here. Are we together here? So that polymer start. Are we together? Are we together? Are we together? So they can simply ask you, name the process by which large molecules are broken down into simpler ones or smaller ones. It's called cracking. Name the type of cracking which involves heating. Thermal. Type of cracking which involves a catalyst. Catalytic. Okay. Now, since we have broken down, okay, these key things we have broken down into smaller ones. They have been broken down into simpler ones or smaller ones, all right? Since we have broken them, okay, so we must crack them. So cracking in such a way, it means this. Best example, here we have what? We have propan. So this propan, take note, this propan, this propan, it is what? It is an alkene, an alkane, right? So this is an alkane. So propan is an alkane, right? So we must crack propan so that it becomes smaller. You see, so we have to make this propan to become smaller. You see, this is what we are talking about. So we must crack here and also we must crack here. This is what we're talking about. Okay. Now, what we're going to do, we all know that propan is general formula. It's C3H what? 8. Now let us crack it. So how are you going to crack it? It's way too simple. So here we are having what? C what? C3. So here it's 1. Then you see 1. So here I've put 1. Okay. Then here it's what? H8. So I will end up saying H4 plus what? How many have I remained with? 2. I will end up saying C what? 2. Are you seeing what I'm doing? It's C, it's 2 plus 1. It's 3. It's more like just you are cutting these numbers into 2. Okay, so 1 plus 2 is what? 3. Then here I'll end up saying C what? H what? H4. Okay, show how propan it can be cracked. It can be cracked like this. Okay, this is how it can be what? It can be cracked. Okay, you see, it can be cracked like this because if you add everything here, it must brought you back to this part. Okay, because if I do 1 plus these 2, you see, they are going to give me what? 3. You see, if I do 4 and this 4, you see, they are going to give me 8. This is what we're talking about. Okay, it's more like they have also asked me, let me say, to crack down. Okay, they've asked me to crack down this part. Okay, crack this part. What are you going to do? This is C4. You can simply say here it's C2. Then here, since we have 9, you can say it's 4 plus what? C2 H what? H5. Like this. Take note these numbers which we are using. When you add them, they must give you these numbers. So 2 plus 2 is 4. Then 4 plus 5, it's what? It's 9. This is how you get to do what? To crack. This is how you get to do what? To crack them. Okay? This is how we get to do what? To crack them. This This is how you can crack them. Is it hard to crack these guys? Is it way too hard? How you can crack them? Is it hard? So this is how we can get to do it, to crack them. Okay. Are we still together or people are sleeping? Okay. No need for drawing. We are just cracking here. There's no need for us to start drawing. We are just cracking. We are just cracking here. We are just breaking them. All right. Then now, so we have something big. Then now we have made something smaller. You see, so we had something big, then now making something small. This is what? Cracking. Okay. So here it was big, but here it's what? Smaller. So the process, cracking, the breaking down of large molecules into smaller one, into simpler or rather smaller ones. That's what cracking is all about. All right. Now, when we make these smaller ones, they may be in form of what? Crude oil. These smaller things, these smaller molecules, they may be in form of what? Crude oil. No wonder alkanes are also called paraffins, all right? They're also called what? Paraffins. Now here, guys, you are going to be given this diagram in a paper, which is called what? The fractionating what? The fractionating column. When I draw it, some of you, you are going to say that, oh, we normally see this question, okay? So this diagram simply shows that the cracking part has already taken place. Now these are the small molecules now which have been used. So the big, they have been cracked. So these are the smaller molecules which will be collected here. You see, so this is what we're talking about. So this the thing, okay? I have already explained that. Sylvia, where were you? I've already explained that. Thermo means heat, catalytic means a catalyst. The other one involves heat only. Catalytic involves a catalyst and also heat. It involves both heat and the catalyst. That's all. Okay. Hope some of us in papers we have come across this diagram which appears to look like this, isn't it, guys? How many have come across the diagram which appears to look like this? This is the fractionating column. Take note, this is the fractionating column. How many have come across a diagram which appears to look like this? Okay, so this is the fractionating column. Okay, so this is what we call the fractionating what? Column. Okay, so now what you should do, they are going to ask you to name the first product which will be produced at A, at C, at D, at E, at F, at A, B, C, D, E, F, G, at G. You see, they're going to ask you that, okay, name each product which will be produced at first. Okay, this product which, so the first pipe is going to produce this one, the second pipe produce this one. Okay, have you seen, guys? Have you seen, guys? Take note, down is very hot, but up is less hot because heat here it's moving in. The heat moves down. That's the main reason why the down part is what? It's hot, very hot, but the bottom part is less because heat is it's getting in from the bottom. You see, okay? Now here, now guys, let us imagine, all right? Let us assume that upon opening the paper, you end up seeing a question which looks like this. Then now you do not have any idea. What can you do? What can you do upon opening the paper? You end up seeing a question which looks like this, then you have no idea. What can you do? Leave it. Oh, that's what you can do. Actually, do you know that, guys, this is way too simple. Okay. Now, guys, what should you do? Seeing this diagram, you should even celebrate. Okay. There is a song here which you should know. The song is like this. Pepe na ke di fuluwabi. Pepe na ke di fuluwabi. Pepe na ke difu difulu wabi. Pepe na ke difulu wabi. Pepe na ke difulu wabi. This is how the song is. Pepe na ke difulu wa. Pepe na ke difulu wabi. This is how the song is, you see, ka? It's Pepe na ke difulu wabi. Pepe na ke difulu wabi. These are the answers which I'm saying here, all right? Don't even laugh, all right? So this is the song, okay? Pepe na ke di follow wabi. Pepe na ke di follow wabi. Pepe na ke di follow. This is how you get to sing it, all right? All right. So yes, there is a song, all right? So guys, pay. It means what? It's petrol. Pay. It means petrol, which means the first product here is petrol. You see, ka? So petrol will be the first product to be what? To be produced. You see, ka? So pay, which means petrol. Okay? So this is what you should do. You should do. Okay? So pay, it means petrol. So we have pay na. Guys, it's a here. Pay na ke. Okay? So pay, which means petrol. Then this na. It's naphtha. Okay? It's naphtha, like this. So the second product which will be produced here, it's what? It's naphtha, like this. You see, ka? So it's pepenake, okay? Then this one, it's what? Kerosene, which means paraffin, okay? It's kerosene, okay? This is what you have to do. Then D, it's what? Diesel. It's diesel. You see, ka? This is what you have to know. So pepe, which means petrol, na, which means naphtha, kerosene, then here D, diesel. Then this fu, which means what? Fuel. It means fuel. Okay. This is what we are talking about. Okay. Then this loo we are talking about. It is called what? Lubricating. It is the lubricating gas. Okay. Then this one, it can be called lubricating wax or gas. These they are just way together. Okay. Take note this one, lure, it can be called lubricating wax or lubricating gas. Okay. Then B, the last one, it's bitumen. It's bitumen. You see, it's bitumen. So the last one here, it's bitumen. This is bitumen. So bitumen is used in maintaining roads. It's used mainly in terms of what? Maintaining roads. Okay, making sure that in road management, all right, maintaining roads that they are way too strong and fit. All right, so the song is like this: Pepe, Pepe na ke di fulu wabi. See, Pepe na ke di fulu wabi, Pepe na ke di fulu wabi. You see, ka? This is what it means. How is it, guys? How is it? How is it? How is it? So this is what it means. So now here, the process by which these gases are collected. So the process by which these gases are collected is called what? Fractional. It is called fractional distillation. So the process by which these gases are collected is called what? Fractional distillation of what? Of air. So the process by which these gases are collected is called what? Fractional distillation of what? Of air. This is what we are talking about. So fractional distillation of what? Of air. That's what we are talking about. Are we sleeping? Are we sleeping, people? Are we sleeping? All right. So that's what it is. Then now, that's why now talk about esters. So they can ask you to define what an ester is. What is an ester? An ester is a sweet. I should make more songs. I will be making them. So an ester is a sweet smelling. So an ester is a sweet smelling what? Substance. So a substance which is what? Sweet, all right, and also smelling good, all right? So an ester is a sweet smelling what? Substance. Take note, we normally, let me say, actually we do come across some sweet smelling what? Substances. So these sweet smelling substances, they can be found in what? In perfumes, okay? Actually, they can be found in drinks, okay? They can be found in cosmetics, all right? Okay, so mainly when it comes to perfumes, when it comes to drinks, okay, most of the drinks actually, they have a nice what? Let me say smell, okay, sweet smelling what? Smell. So here, and also perfumes. So these esters, all right, so it's a sweet smelling substance, all right? So in order for the same perfume to smell very good, take note there is an ester inside. Okay, so one of the uses of these esters, the esters are used in perfumes. They are used also in what? In drinks. Okay, so they do play a very important role. So the main reason why these perfumes they smell good, the drinks and other stuffs, is because of the what? They do have an ester inside. Okay, so now we do have esterification. Take note the difference, guys. We have ester here, which is a sweet smelling substance. Then we do have esterification, which is what? The process. Most of the time, everything which ends with cation like this is the process. Is the process by which the process by which the process by which an alcohol the process by which an alcohol reacts with what? Reacts with an acid. Okay. So esterification is the process by which an alcohol reacts with what? With an acid. Okay. To produce what? To produce an ester. To produce an ester and what? And water, which is a minor byproduct. Okay. So esterification is the process by which an alcohol reacts with an acid to produce an ester and water. So the process by which this alcohol reacts with an acid, we produce what? An ester and also water. That's what we are talking about. Best example, let me say, we have an alcohol here, the group of alcohols, they end up reacting with what? An acid, carboxylic acids. Then now here, we end up forming an ester. Then plus what? Plus water. This is what we are simply talking about. So when an alcohol and an acid, carboxylic acids, they meet together, they react, okay? They are going to form an ester and also what? Water. This is what we're talking about. Now, let us move. Best example here, we can name an alcohol here, okay? Let me say here we have an alcohol, which is called methanol, all right? So this is methanol, okay? Then plus what? Then I have an acid. So an acid here, which is what? Ethanoic, which is ethanoic what? Acid. So I have ethanoic acid here. So when these, they do react, they are going to form what? An ester. They are going to form what? An ester. So when methanol reacts with ethanoic acid, they will form what? An ester. Now, how do we get to write an ester? So take note here. From the myth, you are going to write the myth like this. You write the myth like this. You are going to get this myth like this. Upon getting the first myth, you write L then Y. Okay. So on the alcohol part, get the first myth, then put what? L Y. Okay. Then now this ethanoic. Esters they end with what? Noet. Esters they end with what? With noet. Noet like this. So what you're going to do? Methyl like this. Methyl ethanoate. That's what it is. So this is the ester, you see? So when you see something like this, methyl ethanoate, propanoate, take note, guys. We are simply talking about what? We are simply talking about an ester, which means there is a combination of what? Methanol and also ethanoic acid. Plus what at last? Plus water. You see the way it is, ka? You see the way it is? This is how an ester gets to be formed. This is what an ester gets to be what? To be formed. All right. Then here, the structure of methanol, we all know that here, which means 1, CnH2n plus 1, OH. We all know that here it's 1. Just say here it's 1. Then 1 plus 1, which means 2. Then 3 here, it will be 3. Then OH. This is how it will be. All right. So here for methanol, CH3OH. If you find, okay. Then for ethanoic acid, we all know it's going to appear like this, C, like this. See, this is how it's going to appear. You see, this is how it's going to appear. Take note, 1, 2, then this is the what? The functional group. It ends like this. Then now, what will be the ester? take note, we must form what at last. So what are going to do? So here we are going to get OH. So we are going to collect this OH like this. Then here we are going to get 1H like this. Why am I doing this? After finding the molecular formula like this, and also here the molecular formula like this, get OH. Why OH? Because you must produce water at last. So OH, then here 1H. Take note, H plus H, it means H2. Then we have O, which means water. Then what are we going to do? Get the rest now. What are we having here? We're having CH3. That's what we're having. And with what? O. So here, that's what we're having. This is what we're having, right? Then we have O. You see this O? So we're having this O. This is what we're having. Okay, so we're having this. Then also this side, we are also having this key thing. This is what we're having. So we have this C. How many H? We have 3. We have CH3 like this. Okay, then this double bond which we're having, which is like this. All right, then this C which we're having like this. All right, I hope we are together, people. Don't doze. All right, don't doze, people. I hope we are together. Are we together, people? All right, so if you feel like this part you can make a mistake, you can simply go directly. You can simply do this. If you feel like this part you can end up making a mistake, you can cancel. Okay, you can just go directly. Here we have what? Methanol. Simply do this. We all know C. This is C. How many H do we have? 3, like this. And also here we have this. Then or what? OH. Then plus what? This what is what we're having. This one which we drew. Okay. Then which is H minus here H minus here like this. This is the double bond we're having in this case. All right. You see, if you feel like this, you can make a mistake, you can simply do them like this. All right. You see, then what you're going to do here, you do this. Get here OH, get a pencil. You can do this. Also get here 1H. Get 1H like this. Then the rest now, you can join them. Then you say this. What is remaining here? We have remained with what? H, C, also here what? H. We have remained with this. We have seen what we have remained. 1, 2, 3. This is 1, 2, 3. Then minus what? Minus O. This is what we have remained with. Then now here, take note. You must not go directly putting these. Okay? Take note, we have C. Continue with the C's here. You have to continue with the C's. How many C's do we have? We have 1 and what? 2. You see what I've done? 1, 2. This is the 1, 2. So after copying and paste exactly here, then connect the C's here. Okay, you see, CO, then I've connected this C's. C, C, this is C, C. You see? Then now here, this C, take note, it's having this. You see what is having? Okay, it's having this. Then take note, we're having what? We're having these bonds which are here. We're having these bonds which are here. right? So here, what are we going to do? If you check here, we have this, okay, then the rest, they can be put aside, okay, can be put aside like this. Let me try to make your work easier. Let me do this. Let me make your work easier. You copy and paste here exactly. You do this. H minus here C, then the H. Then here the H down like this. Now I'm afraid that my book will not be enough. Okay, then you connect here like this. You see, then here, upon doing this, what you're going to do exactly, you see, we are having HC minus H. This is what we're having. So you can put this at last. Put this at last, then connect with this one immediately. Minus C here, like this. You see, this is what we're having. Then connect these at last, connect them at last. We have minus, then C. Connect them now at last, like this. Connect them now at last, like this. So this is the ester we are having. So like what I've said, everything which has remained here, write it together with the O, O. Then after just writing the O, look for where the double bond is. Minus the double bond, then this, put them at last, like this. Okay? So here if you check, O, O represents what? The alcohol part. So O, it is the alcohol part. This is the alcohol. Then this one, it is what? The acid part. Okay? So when an alcohol reacts with an acid, we are going to form what? This part, which is called what? Methyl ethanoate. Take note, we are having one carbon atom, and also here we are having two. So here it's meth, then here it's eth. You see, then at last, plus H2O, like this. Okay? So they can end up bringing this structure, then they ask you to do what? To name the ester. Name the what? Name the ester. This is how they can do it. All right, name the ester. All right, so very much essential that for you to know. Like, name the esters. You see here, you will see here, here I'm having this here. The products, the last product is water. You see, name this ester. How are you going to name it? Get a pencil. You see where there is O, O. This O is for what? This O is for alcohol. So this O, it is the alcohol part. You see, then this, okay? This thingy, it is for what? It is for the acid part. You see, this is what it is. It is for the acid part. You see, I hope you have seen here, there is a separation here. O for the alcohol, then this where the double bond is for the acid part. You see, so name, here we have one. It's what? One, which means what? Meth. Okay, you add Y and L like this whenever you are naming esters. Then you come this side now, okay? So 1, 2, 3, 4, which is what? Butanoate. That's all. This I'll get to name. You see, so what was used here? They used methanol, and also here they used what? Butanoic acid. So these are the reagents which they were used. So once upon reacting this, we form water at last. You see, huh? So this is simple now. So you start with the alcohol part, then end with the what? End with the acid part. This is how you get to name. If they want, they can even swap. They can even do this. You see, huh? They even do this. Okay, here they do this. You see, huh? They can even do this. Then they do this. They just want to see if you know. You see, huh? You see, huh? They have swapped it. You see, huh? They have swapped it. So look for where O is sequoid, like this. You have seen where O is, huh? Then also here, this one sequoid also. Separate it. You have seen, huh? So where there is O, it is the alcohol part. This is the first part. You are going to start with this one, which means is the what? Is the acid part. It's the acid. So alcohol part, how many carbon atoms? It's one. So you write meth, then Ly. You see, huh? Then how many carbon atoms here? One, two, then three. Three, which means wait, it means propanoid. Propanoid. Like this. This is how you name. Is it hard? Is it hard, guys? Okay. So the O stands for the alcohol. This like a double bond thing stands for the acid. So start with the alcohol, then end with the what? With the acid. How is it? How is it? How is it? Simple, right? So this is how we get to name the esters. Way too simple. That's all. So the last product which is formed at last is what? It's water. So the last product which is formed at last is water. Okay, so water is formed at last. Okay, because when an alcohol reacts with an acid, an ester is formed plus water, so water is what? Is formed at last. Then that's all about esters. It's the simplest topic ever. That's all about esters. This is how they end. That's all. Then now polymers, so that we sleep. Polymers. Polymer. You see? Guys, take note that the word poly means many. Okay? So a polymer is a large what? Is a large molecule. That's what you have to understand. Is a large compound or a large molecule formed when two or two or more monomers combine. This is what we're talking about. So a polymer is a large molecule formed when two or more monomers combine. So it's like this. Monomer means small, guys. Monomer is a smaller what? Molecule. So a small molecule, we call it to be what? To be a monomer. Okay. Now here it's more like this. We have monomer, which is small, plus monomer, plus monomer equals what? Equals polymer. That's what you have to know. Okay. So a polymer is a large molecule formed when two or more monomers combine. So when we combine this and this, we form a polymer. That's what we are talking about. All right. So now here, now after understanding what a polymer is, so here, what we have to understand is that we have types of polymerization. Okay, types of polymerization. Take note, guys. Polymerization is simply the process by which two or more monomers combine together to form a polymer. Okay, this one is more, it's more like just the process. All right, the same definition here, you just what the process here, saying polymerization is the process by which two or more monomers combine together to form a polymer or to form a large molecule. That's what we're talking about. All right, I hope something has been grasped here. I hope something has been gotten. I hope something has been gotten. I hope something has been gotten here. Then types of polymerization. Number one, we have what you call additional polymerization, and also we have what you call condensation polymerization. So we do have two types. We have additional polymerization, and also we have what you call condensation polymerization. That's what we're having. All right, we are having two types of polymerization. All right, now under additional polymerization, we are having these key things. All right, take note, additional, it comes from the word adding, which means we will keep on adding. This is what it means. Okay, best example here is more like when I say under addition, it's more like when I say 1 plus 1 plus 1 equals to what? To 3. You see, so when I say 1 plus 1 plus 1, it means what? 3. This is what it means. You see, so if I say 1 plus 1 plus 1, it means 3, which means I was adding this in order for me to come up with this one. All right, I was adding this in order for me to come up with what? This one. Okay, now here they can simply do this. Take note, examples of this additional polymerization, they can simply ask you to draw the structure of polyethylene, draw the structure of polypropene, even drawing the structure of PVC, which is polyvinyl chloride. Okay, poly means many, so many ethene, many propene, then also here a structure which we end up having what? Chlorine inside. Now let me show you one sample. We have one question here. We have one question which says, number one, draw the structure. Draw the structure of what? So draw the structure of polyethylene. You see, so draw the structure of what? Polyethylene. Okay, so this is the question. Okay, I hope we are together, guys. I hope we are together. Under additional polymerization, we will keep on adding. You are going to see from the structures. Okay, we have two types of polymerization. We have additional, we have condensation. Okay, I want to show you now how we get to answer the question. All right, and show repeating what? ensure repeating units. You see, so this question will cost 3 marks. Draw the structure of polyethylene. Guys, poly, poly means many. So they want you to draw the structure of polyethylene. Polyethylene meaning what? Here we want many ethene. That's what they want. So it's more like they want this. So here, when you see these questions like this, you just say ethene, okay, plus ethene, plus ethene. This is what it means. Since poly means many, which means many ethene, which means ethene plus ethene equals what? Equals polyethylene. This is what it means. You see, this is what it means. You see? So this is the first key step. Okay, is it okay for the first step? This is 3 marks, guys. Okay, is it okay? Is it okay when it comes to the first step? Is it okay when it comes to the first step? When it comes to the first step, once they say draw the structure of polyethylene, so what are you going to do? Check polyethylene. Come up with the 3 ethenes, which means there are more in order for you to come up with what? The polyethylene. Okay. So what are you going to do? Okay, interesting. So what are you going to do? We all know that we are talking about what? Ethene. It's what? Ethene. Okay. What you have to know, these additional polymerization are what? Are alkenes. Okay, are alkenes. All alkenes are additional polymerization. All alkenes, they fall under this party. Okay, all alkenes, they fall under additional polymerization. No wonder, check, we have what? Polyethylene, polypropene, propene. These are what? Are alkenes. So all alkenes, they fall under what? Additional polymerization. That's what you have to know. Okay, we know concerning the part of ethene, the general formula is what? The general formula is what? CnH2n. Okay? So what are you going to do? If it means what? 2. So here where there's n, we put 2, H2, then here also N2. So what is the answer? C2, H what? 4. You see, okay? I hope it's clear here, guys. We can do this on our own, right? We can do this on our own, right? How to solve this, okay? So take note, solve for the ethene. Okay, the general formula for all alkenes is this one. Okay, CnH2n. If means 2, where there's n, put 2. Okay, so actually, please help us with more concept. Maybe you can break it into smaller monomers. All right, we can do this part, right? So concerning this part is safe, right? It's safe, right? So upon finding this C2H4, you come here. Polymers are simple, guys, but I don't understand why people, they end up saying C2H what? 4. Also here, you do C2H what? 4 plus what? C2H4. You see what I'm doing, huh? Then now equals what? You add 2 plus 2, 4. 4 plus 2, it's 6, which means what? C6, like this. 4 plus 4, 8. 8 plus 4, 12, which means H12. Like this. That's what you should be doing. Now, you guys, when you hear my polymers, you state, what are you afraid of? Right? How is it, guys? How is it? Also here now, you draw the structure down, okay? C2, which means what? C double bond 2. Take note, guys, they are alkenes, ethene, okay? Double bond. So H4, also here, also here, and also here, like this. You see, ka? Also here you do the same thing. See, a double bond, see, like this. You see, ka? This is how you get to do them. If you want, feel free, you can even bend these edges. They can bend like this, okay? See, like this, like this. If you want, like this, and also here, like this. Then you just say equals, okay? This is what we're talking about. Is it safe here, guys, doing this? Can we manage to do this, guys? Can we? Can we manage to do this? We can manage, right? We can manage, right? Mhm. Then here, what you're going to do, we follow. It's what? C6. You see, ga? C6. Meaning what? It's more like just we're saying 1, 2, 3, 4, 5, 6. Here, at the ending part, your product must not have the double bond. Okay? So here the double bond must disappear. So the double bond here, they will disappear. They are only here. The double bond here will disappear. So we'll say 1, 2, 3, 4, 5, then what? 6. That's what you should do. So here the double bond disappears. Then now we start covering now with the H. Let us start. We say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10, 12. You see, ka? You see the way they are. Mhm. Then now here, we end up getting 2 marks, and they have said what? And show repeating units. We should show repeating units. Meaning what? We should show where things are the same. Like here, take note, we have C, C. It's the same. So get the pencil and do this. Okay, you do this. It's more like you are covering. This is the repeating unit. Take note, this one and also here, it is also repeating. You see, ka? Also here, it is also repeating like this. You see, ka? Also here, it is also repeating. So here, repeating, and also here, repeating. Also here, it is repeating. Where it is repeating, where it is going 2 by 2, 2 by 2. You see, ka? So here we have 1 repeating unit, 2 repeating unit, 3 repeating unit. So how many repeating units do we have? We have 3. So we have 3 repeating what? Units. Since we have 1, 2, then 3. Altogether there are 3. So we have 3 repeating units. That's what we have. Chapwa, you end up getting marks for free. Is it hard? Is it hard, people? Is it hard? How is it? How is it? How is it? Or if they want, they can just end up bringing this structure. Then they ask you to name the polymer. Okay? Name the type of polymer. See? You see, ka? Then This is the question. Name the polymer. You see, ka? Your question will just come like this. You see, ka? Name the polymer. Name the polymer. So how are you going to name the polymer? Check the repeating units. Here it's what? 1. And also here it's what? 2. And also here it's what? Here, like this. You see, ka? How many carbon atoms do we have? We have 2. So we have 2 carbon atoms, which means what? Eth. And all additional polymerization are what? Are alkenes. So the polymer is what? Poly what? Ethene. This is what it means. You see, ka? This is how you get to name. Okay? Then they say show the repeating units. You see, ka? Show the repeating units. So these are the repeating units, okay, which means they are what? They are 2. Okay, so these are 2. Okay, this is how you get to do polymers. Okay, so name the type. So name the type of what? Name the type of polymerization it is in. All right, so name the type of polymerization it is in. Take note, this it falls under what? Additional. Okay, additional what? Polymerization. Chapel. You see, ka? How is it, people? How is it? I think I've helped you. Oof. I'm even tired now. How is it? How is it, people? Are we getting there? We are getting there, right? How is it? How is it? How is it? Then the other question. Draw the structure. So draw the structure of what? So draw the structure of polypropene. So you do the same thing. Draw the structure of polypropene and show the repeating units. Okay, so take note, poly means many, propene. It's more like we are saying propene plus propene plus propene equals what? Polypropene. Polypropene. So what are we going to do? The same thing which we are doing. Take note, all additional polymerization, they do, all alkenes, they fall under additional what? Polymerization. The formula CnH2n for all alkenes. So prop, which means 3, number of carbons here 3, H then 2, here also 3, which is C3, H 2 times 3, which means 6. So here we have C3, H what? 6 plus C3, H6 plus C3 H6 equals what? 3 plus 3, 6 plus 3, 9. C9. 6 plus 6, 12. 12 plus 6, 18. H18. Like this. You see? This is what you do. Then now let us start their structure now. Here we move C minus C minus C. Like what I've said here, guys, choose where the double bond will be. If you want, it can be here or here. But take note, the other side must breathe. Let me say it's here, all right? So here, how many 6? How many H? 6. So it's 1, 2, 3, then here, 4, 5, then here we are having what? 6. The other part must breathe, okay? When you're having a double bond, when you're having more carbons like this, where you put the double bond, this part must breathe. So it's very much important to even put just the double bond at last, so that when counting, it's way too easy. Even here, the same thing, C, C, C. So it's H, H, also here, H. Then here, you do the same thing. Here, H, even on top, H, here, even down, like this, C, C, C. Here, the same thing which we are doing, H, also here, H. Then here, H, here, H, double bond here, H, like this. Then now here, on the product part, no double bonds must be shown. How many C's? There are 9. So these C's, they are 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. You see? Now, what are we going to do? Here, we have to be very much careful a bit, okay? Because these are not polyethylene, okay? These are what? Polypropene, okay? These are what? Polypropene. Let us be careful a bit. These are what? Polypropene. Guys, prop means what? Prop means what? Prop means what? What does prop mean? The prefix? What does it mean? It means 3, right? It means 3 carbon atoms. That's what it means. 3 carbon atoms. Now check, guys. Whenever we are doing the repeating pattern, if we go back to polyethylene, what were we doing? We are doing this. Whenever we are showing the repeating pattern. So this is the repeating pattern, right? Which we are showing. For polyethylene, we are doing this. You see? So for showing the repeating pattern, we were doing like this. Okay, we count 1, 2, which is ethene. But take note here, guys, we have propene. Propene, which means 3. We must have what? 3 carbon atoms. So here, we must show 3 carbon atoms. So what we're going to do, it's what? C, which is 1, 2, then here down. Okay, so here we say down, we also write the C. C, okay, CH what? 3, like this. This is what you should do. Why? Because this is 1 carbon, 2 carbon, 3 carbon. You see, they were going to make what? 3 what? 3 carbons, which is what? Propane. Okay. Here you say 1, 2, you write CH3. This 3 in actual sense simply means what? I am coming. Okay. Let us first finish here. 1, 2. Also here, 1, 2. Do the same thing. CH what? 3. Also here, do the same thing. 1, 2. Do the same thing. CH what? 3. 1, 2. Okay. CH what? 3. This is where it ends. You see, then now what are going to do? Here, an H, 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 here, an H. You see, this is what we're talking about. Okay, so this is what we are strongly what talking about. Okay, now if you check verbal, these 18 which you are seeing here, these number of carbon atoms, they won't even reach here. Let us even try to count 1, 2, 3, because this space has been gotten already. You see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It will only cut us 16. Okay, so it is not even necessary. Whenever we are talking about propene, all they want is for you to show these parts. Okay, because the number of hydrogen atoms, they will not what? They will not be complete. All right. So what you're going to do, the repeating units, take note, guys. See, so 1, 2, you show CH3, 1, 2, CH3, or if you want, you can put it on top. Okay, show the repeating unit like this. Show the repeating unit like this. Show the repeating unit like this. The repeating unit, repeating unit, repeating unit, repeating unit, repeating unit. 1, 2, 3, 4. So we have 4 repeating unit. 4 repeating what? Units. Like this. I hope 1 or 2 things have been gotten. So what matters a lot for you, it is to show this CH3 down, because this C means 1 carbon, this C 2 carbon, 3. It is what? Polypropene. That's what it means. It doesn't matter the number of hydrogen you have listed or written there. All what matters is for you to show this and also the repeating units. Okay, how is it? So we end up seeing questions like this. End up seeing questions whereby they will appear to look like this. You see, asking you to name the type of polymer. What is the name of this polymer? What is the name of this polymer? Name the polymer. Name the polymer. Mhm. Name the polymer, name the polymer, name the polymer. What is the name of this polymer? Okay, so the name of this polymer is like the following: polypropene. Okay, polypropene. Polypropene. You see, this is polypropene. Okay, No. Down. No. Let me say we have this one, you see. We have this one, you see. We have this one. See, I want you to see this one. You see this one, You have seen this one, check. We have what? 1, 2, and also here we're having 2 carbon atoms. So if you check, we have 1, 2, which means 2, 3, then 4. You see, so we have 4 here, which is what? Polybutene. You see, we are only paying us extra attention to the number of carbons. That's what we want, not this part. All right, we don't want this part, only this, the number of carbons. So if I put 2 here, 2, which means 2, then here it's what? 2, 3, then 4. You see, which means what? Butene. Okay, butene. So if I put a 3 here, so 3, 4, then 5, it's polypentene. You see, this is what it is. Guys, since we know that, okay, 2 means eth, 3 means prop, guess what I'm talking about. Okay. I hope you have gotten it. This is what it is. So here we have 2, then 3, then 4. This is what I'm talking about. Clear? So this is what it is. I hope I've helped. Yeah. Then now this one, H, C, like this. Okay. H, C, H, C, H. Then down we have Cl like this. You see this one? We're having Cl, which is chlorine. So this polymer is called the PVC. Okay, so this polymer is called what? Polyvinyl chloride. So this is the name of the polymer. It's called polyvinyl chloride. You see, take note, it's having what? It's having, okay, it's having Cl. It's having Cl and also here Cl. So Cl means what? Means chlorine. This is what it means. Okay, so this is polyvinyl chloride. This one, I hope something has been gotten, grasped. All right. So then now, under condition polymerization, so under condition uh, condition of polymerization, we do have these two major examples. We do have terylene and also nylon. Okay, we do have this terylene and also nylon. Okay, whereby terylene, its chemical name. Okay, so it's what? It's polyester. Then this, it is what? Polyamide. Yeah. Guys, sorry, I have to go for invigilation tomorrow. I will be late actually. This is 0241. So I think I've helped, guys. If you want video when it comes to continuation, I can send you on WhatsApp. There is a video which I can send you for WhatsApp. It was done by my friend who finished it. I can send you a link so that you continue. All right. So if you want a video, just inbox me on WhatsApp so that I send you the link. All right. I send you the link. So this is the ending part. All right. So my line 07777 37. This is my WhatsApp line. So thank you very much.